So let's quickly walk through the demos for clustering in MATLAB. Here's where I'm generating some data that has two clusters. And the way I generated the data is essentially by having um, two lists, uh, one with mean 2, 1, and another with mean 1, 2, and then having some random scatter around those two means, and sort of putting those two lists together is how this data was generated. Um, Same here. And then here we had three different means, and I generated some bunch of data points around each mean and put all those data points together. And that's how this three cluster data set was created. Okay, so here is where we are actually discovering the three clusters using k-means in MATLAB, k-means clustering in MATLAB. So P is P1 list, P2 list, where P1 list is the x coordinate, so to speak. P2 list is the y coordinate, right? And P has x, y, and if there are more dimensions, it's how many ever dimensions there will be columns. And we just go k means P comma 3 if 3 is the number of clusters. So k clusters equal 3. And then it outputs two quantities, IDX and then C. Let me comment this out and run this. Oops, clusters. Okay, so once we run this thing, it's pretty fast. Looks like it's a very fast algorithm. C gives you 3 rows, each with 2 columns. What do these 3 rows mean? It's actually the means of the 3 clusters that we have. Okay, so these 3 rows are the 3 means we have. Because we have 2-dimensional data, each of the 3 means has 2 numbers. Okay, so those are the means, and we can ideally plot the 3 means here, here, and here, which we will do that in the next cell. And then what is IDX? IDX is basically this list, which is which has numbers 1, 2, 3 in some order, and it will, if you'll notice, it's got 300, and then if you go size p list, that's exactly size p, I suppose. It's exactly 300 rows. So IDX basically tells us which set each of the rows of the data set corresponds to, which of the 3 sets. So the very last data point corresponds to or belongs to set number 3. The next last data point corresponds to set number 1, and so on. So that's what that index list contains. And then we can visualize the 3 clusters. Here all we have done is plotted the data points belonging to the 3 sets, IDX equals 1, IDX equals 2, IDX equals 3, in 3 different colors. So let's do that here. Let me close all. So this is the original data. See, and then we can do this, where we had the original data all the same color. Now we've just plotted the same data points, but 3 different colors, and the black dots are the means. Okay, so what k-means did was essentially try to compute the 3 means in the 3 sets associated with the 3 means that sort of characterize the 3 clusters. Okay, so that's all there is for k-means. In the homework, what we're asking you to do, instead of P has 2 columns, we're asking you to do P with 784 columns, basically the MNIST data set. And all you need to do is replace this with the MNIST data set. And then you can, each mean um, will correspond to some kind of an image. Of course, each data point is an image, but the mean is also an image. The mean that corresponds to each cluster is an image. And then you can see if you divide the data set into 10 clusters, let's say, if the mean of each cluster naturally looks like the numbers 1, 2, 3, 4, etc. Right? So if you divide the data set into 10 clusters, are the 10 clusters exactly the 10 numbers? That's something to check. Okay, so that's part of the homework problem. So that's it for k-means, and the next topic is dimensionality reduction.